This happens with everyone. Tangled code, confusing logic. You wrote it, but now you can't even understand it. Well, guess what? There are few simple understandings transforms beginner coders to the professionals. It's simple and it will make your code crystal clear. Get ready because today we are solving that code mess together. Welcome scholar, I'm so excited to discuss with you about few fundamental concepts of Python programming. Think of learning Python like learning a new spoken language. You need to understand its grammar rules, that's syntax. You need to understand the meaning behind the words and sentences, that's semantics. And sometimes you need to add little notes to yourself or others to clarify things. Those are comments. It's very simple. Here we are going to break down each of these concepts with simple and clear explanations with examples. The goal is to make sure that by the time we are done, you will not only know what these things are, but why they are so important for writing code like a pro. So open up your Python editor and let's start coding together. Let's start with syntax. In programming, syntax is simply the set of rules that define how a programmer must be written for the computer to understand. It's the grammar of Python. If you break these rules, Python will throw a syntax error. This is the way of Python to tell you, hey, I don't understand what you are saying. See, this code is to print a simple output, hello scholar. And as it is syntactically correct, that's why showing the results properly without any error. Now what will happen if you forget to close the first bracket at the end? Python will throw an error instead of printing the output. It will also tell you what kind of error this is and what you need to correct. So always look at the error you are getting. In maximum cases, Python will tell you in which line the error is and what needs to be corrected. Another example is here. If I make mistakes in between, the error message going to give me a clear instruction about the error, line number, and the error type. Let's discuss some of the important rules of Python syntax. Python is a case-sensitive language. That means small letters and capital letters act differently. Here, if we assign a variable name, say scholar, and another variable name, say stream, though both the variable is name, but Python will take these two as two different variables, as this is in small letters and this starts with a capital N. We can use these two variables distinctly. Now I'm printing this name and the output is scholar, and if I print this name with capital N, the output will be stream. This means same variable but different lettering are two different variables. One more thing to remember here, all the keywords of Python must be in small letters only. Here, if I change this P in capital, there will be an error. So whenever we are writing code and naming the variables, always remember that same spelling not always mean the same things. Check its case sensitivity. Another most unique and important features of Python syntax is indentation. Now, what is indentation? Indentation is used to refer the level of nesting of a code block. Unlike many other programming languages that uses curly braces or semicolons to define the block of code, Python uses white spaces, specifically known as indentation. This isn't just for making your code look pretty, it's a mandatory structural element. Indentation tells the Python interpreter exactly where the block of code begins and ends, especially within if statements, for loops, while loops, and function definitions. If your indentation is off, you will get an indentation error. See how print 10 is greater than 5 is indented. That tells Python it belongs to the if statement. That means the scope of this code to execute only this if condition is true. Otherwise, Python will not execute this part of the code. Now, if we mess that up, the error message will come up saying it's an indentation error. No matter how many lines this code block consists, all the lines must be correctly indented. If any of the line misses indentation, this will be an indentation error. Python's official guideline recommends using 4 spaces for each indentation level. This consistency makes Python code incredibly readable and easy for anyone to follow. In case of nested loop or nested condition, to differentiate these two blocks of code belongs to two different if, we put the indentation separately. For our easy understanding, we can categorize the syntax errors in 5 different categories. Missing or mismatch punctuation, which includes any missing parentheses, brackets, braces, quotes, commas or colons. Incorrect indentation will lead to an indentation error. Misspelled or misused keywords, which includes the use of a keyword incorrectly or misspelling it. When we use a special characters or starting a variable name with a number, Python can't recognize this. We will talk about Python variables naming convention some other day. For now, remember that the correct way to naming a variable in Python programming is to start the name with any letter or underscore. And if you have multiple words in a name, then separate them with underscore instead of a blank space. Another error we may face that is missing required elements. For example, an else clause without a preceding if. We will talk more about the errors in Python more deeply on another day. Now let's talk about how to prevent these errors to occur. The most easiest solution to prevent these errors proactively, I highly recommend using a good code editor or integrated development environment like VS Code or PyCharm. These tools have features like syntax highlighting and linters that check your code for errors and style issues as you type. It's like having a personal grammar checker for your code, catching mistakes before you even run your program. So next feature of Python syntax is new line statement termination. That means every new line is indicate the termination of the statement of the previous line. Time comes when you will be a professional coder, then you will face a different kind of a problem. Sometimes a statement becomes too long to fit in a single line. But you can't press the enter for a new line, as Python treat this the termination of the statement. There are 2 ways you can handle this problem: explicit line continuation and implicit line continuation. To write the statement in the next line with continuation, simply add a backslash at the end where you want to break the line. This is known as explicit line continuation. Using a backslash at the end of a line to tell Python that the statement continues on the next line. This is very useful for long mathematical calculations or function calls with many parameters. Now, implicit line continuation allows long statement to be split across multiple lines as long as the code is enclosed with parentheses, brackets, or braces. Python automatically knows that the statement continues on the next line, so you don't need a backslash. This is super handy for defining multi-line lists, tuples, dictionaries, or for structuring long function arguments. Here we are adding these numbers. If we press enter here, still the interpreter can understand that these 2 lines are a single statement, as this is enclosed with this parenthesis. Let's take another example. Suppose we are assigning a list and going to the next line, though this entire thing is in a single list. Here also the interpreter will understand that this is a single statement, as this is also enclosed with brackets. Now the question is, why bother with multi-line coding? The biggest reason is to boost readability and maintainability. Imagine a line of code that stretches endlessly across your screen. It's a nightmare to read, especially on smaller monitor or when you are reviewing code with a teammate. Breaking these lines into logical segments make your code much easier to scan, understand quickly, and debug efficiently. It also leads to better organization. Multi-line formatting helps structure complex expressions, function calls with many arguments, or long data structure like lists and dictionaries. By visually grouping related elements, the structure of your code becomes immediately clear, which significantly improves comprehension. And finally, it helps with adherence to style guides. Python's official guide recommends that line of code should be at most 79 characters long. See the difference. The ability to split statements across multiple lines isn't just a convenience, it's a fundamental practice that directly impacts code quality and developer efficiency. Easier to read code means fewer errors, faster debugging, and a smoother development process overall. Okay, so these are more or less about Python syntax rules, which are very essential for professional coding. While syntax is about the form of your code, on the other hand, semantics is all about the meaning of those statements. A program can be syntactically perfect, following every Python grammar rule, yet still be semantically incorrect if it doesn't make logical sense or perform the action you intended. Think of it like this sentence: the square circle ate the color green. Grammatically, it's correct. It has a subject, a verb, an object, but it's meaningless. A square circle doesn't exist, and colors don't eat. That's a semantic error in natural language. Now, this is syntactically structured correctly. Print is a function, divide is an operator, but it's semantically invalid because division is not a meaningful operation between a string and an integer. This would lead to a type error at runtime. Understanding semantics is crucial because it dictates how the Python interpreter will actually execute your code and what your program will do. It's about the logic and behavior. Python is an interpreted language, meaning its instructions are read and executed by another program called the interpreter. The interpreter first checks for the syntax, then proceeds to understand the meaning and execute the operations. If your code has correct syntax but incorrect semantics, it won't do what you want. And these semantic errors can often be much harder to detect and debug than syntax errors, as they only show up when your program is running. Now, if you see this example, the code takes two inputs from the user and calculate their sum, but input returns strings. That means the plus operator performs string concatenation instead of the numeric addition. This result is a semantic error because the code does not produce the expected numerical sum. This code is syntactically perfectly correct. The programmer likely intended to add the numbers as integers, but the code treats them as a string. This is a semantic error because the meaning of the plus operator is misinterpreted within the context of the code. Python will not raise any error message during execution because the syntax is correct. However, the output will not be what programmer intended. Now let's talk about a simple yet incredibly powerful tool, that is comments. Comments are programmer readable explanation or notes embedded directly within your code. The Python interpreter completely ignores them during execution. So the question is, if they are ignored, why they are so important? Their value for human understanding is immense. The primary importance of comment lies in the enhancing readability and understandability of your code. Code that is clear and well explained is easier for other programmers to understand. Also, it helps you to remember your own logic, especially when you revisit code after a long time. This is crucial when working on large projects or inheriting code from others. They clarify the purpose and behavior of complex or non-obvious code segments. They provide context, assumptions, limitations, or external references related to the code. Comments make debugging and revisiting code much easier. By explaining designing choices, they guide future modifications and help diagnose issues. You can even temporarily comment out sections of code for debugging. In team environments, comments are vital for ensuring all developers quickly grasp the intent and functionality of different parts of the code base, reducing misunderstandings and improving efficiency. Comments are basically a bridge between the machine executable code and human comprehension. They transform raw instructions into a narrative that explains why the code exists and what it aims to achieve, making the programming in a more collaborative and sustainable. Basically, there are two ways we can use the comment in a coding: single line comment and multi-line comment. So it is very obvious when we need to write small notes, we will use single line comment, and on the other hand, multi-line comment is used for a long explanation. Single line comments are the most common and straightforward way to add notes to your Python codes. They are denoted by the hash symbol. Anything that follows the hash on the same line is considered a comment and is completely ignored by the Python interpreter. We can place the single line comments in two main ways. Standalone comments occupies an entire line, separates from any code. They are great for documenting the overall process or logic of a section of a code. But inline comments are placed on the same line as a line of code, typically after the code itself. They are valuable for quick explanations or clarifications for specific line. Now, if we talk about multi-line comments, Python doesn't have a dedicated syntax for multi-line comments like some other programming languages. However, we can achieve the same effect using two common methods, either by using consecutive single line comments or by using triple quotes, either single or double. But the most explicit way is to simplify prefix each line with a hash symbol. Okay, that's all for now. Thank you so much for joining me on this deep dive into Python syntax, semantics, and comments. I hope you feel much more confident in understanding how Python works under the hood and how to write code that's not just functional but also beautiful and easy to understand. Remember, the journey of learning to code is all about consistent practice and building on your foundations. So keep experimenting, keep building, and don't be afraid of those error messages. They are just Python's way to teach you. If you find this video worth of your valuable time, give it a big thumbs up, do comment what to discuss next. Let's build this together, one content at a time. पढ़ाते रहे, पढ़ते रहे. जय हिंद.